This is question 6 of 2019 higher level leaving cert. Part A is this question here. Now, you might be surprised because you're looking at the question in front of you, which, by the way, they're in the comments below. You might be surprised because there's a wall of text there. It looks very confusing. But really, they're just asking you to solve for x. It's just a simple equation. They're asking you to solve for x with one little exception. They want the answer to look like this. X equals a square root 2. That's what they want the answer. A will be a natural number, so 2, 3, 4, 5, 6, 7, 8, 9, 10. Some normal number. That's all. That's the only exception they've made. And you can't use a calculator really, although modern calculators will do this for you, unfortunately. You have to show your work. But that's true for lots of times when a calculator can answer your question. I'll go ahead and rub this out. We don't need that. We'll just solve it as normal. Add 6x to both sides. 5x to both sides, and we'll get 6x on the left. Add square root 32 to both sides. Square root 128 is still here because we can't add these together like normally, because square roots do not work that way. They do not add together nice and easily. And that's why they give us that clue of how they want the answer to look. Because what we can do is take out common factors. The square root of 2 divides into both of these. Divides into this, the square root of 64. Multiply these together, we get back to 100, and then square root of 128, plus the square root of 16 here. And these, thankfully, and as designed by the question, these are in fact nice and easy. They are 8 plus 4, and that is equal to, that's 12 multiplied by square root 2. We usually just write our numbers in front of square roots. No reason, it just it gets a little confusing if it's after here. It can be easy to confuse one of the numbers to go inside or outside. And this is 6x is still equal to this. So x is equal to 12 over 6 square root 2, which is equal to square root 2. That's the format they wanted us. That's it. That was a simple enough question. They're really just asking you, do you know how to multiply and divide square roots? And that's it. A part 2 is simply this set here. It says A equals, I've left the A out. This is just 4 numbers inside this set. Very complicated looking, but it shouldn't be terrifying to you. Square roots, part 1, we just learned how to deal with square roots, which is actually going to come in very helpful in this part. K squared, we don't know K, but it doesn't actually matter in this point. The point is that this K is equal to this K, is equal to this K, is equal to this K. So the question simply asks us to show that the mean is equal to the median. Show that the mean is equal to the median. So how do we do that? Let's do the median first. The median is equal to the middle number when we put them all in order. So all of these in order would be 32, 50, 98 should be there, and 128. Now, I don't want to waste so much ink writing it out again in order. I think we can all get that. 32, 50, 98, 128. So what's the middle number? Unfortunately, there is no middle number when there's 4 numbers. So we're going to have to take the middle 2 and average them. So the median is equal to the middle numbers, that's 50k squared, plus square root of 98k squared, divided by 2. That's how we get the mean of them, which we're going to do next. So that's how we get the median when there's an even number of sets here. So let's add these together, and we'll take a hint from part 1. That's the reason part 1 is in this question. That's the reason they weren't separated. They are very similar. The hint here is to find the common root, and that would be 2 and k squared, in fact. 2 goes into this, 2 goes into this, k squared goes into both of them. There may be some bigger numbers go in, I'm not sure, but there's a reason I'm going to use 2k squared, because I can see a little bit ahead. When I divide this by 2, I get square root of 25. That's an easy number, that's 5. When I divide this by the square root of 2, I get the square root of 49. That's a nice easy number as well. This is all divided by 2 still. So let's see what we've reduced this down to. Square root of 2k squared. Well, first of all, this k, I could have done this at all points, by the way. Square root of k squared is just k, multiplied by the square root of 2. Inside this bracket is 5 plus 7, divided by 2. So what's that? That's 12 divided by 2 is equal to 6k square root of 2. That's the best I can do. That's the median. But let's hope we do the mean and it comes out the same. That's my goal right now. We won't have to do any more with this because I don't know how to do any more with this. So the mean. We often write the mean is equal to x with a bar on top of it, by the way. If you see this instead, if they ask you to find that, they would usually tell you, they'd usually mention x more when in the sets. But anyway, it doesn't really matter too much. The mean is equal to, right, it's going to take a lot of ink. All of these added together. 32 k squared, yeah, I'll have to just write them all out, unfortunately. 50k squared, 98k squared, it's all square rooted. Plus, it doesn't matter which order I put them in. This is an unordered set. The mean doesn't care what the order is. I could write them out in any way. But usually I just write them the way I see them. Okay, and this is all then divided by the total number of things in the set, 4. So we just add this up just like we did here, just like we did in part 1. We find a common number, which is k square root 2. Just like here, it goes into every one of them. It goes into this square root 16 times. It goes into this square root 25. It goes into this square root of 49. And it goes into this one, the square root of 64 times. Which is equal to k square root 2. And what's this? 4 plus 5 is 9. Plus 7 is 16. Plus another 8 is 24. Oh, sorry, I'm sorry, I've left something out here. This is all divided by 4. All divided by 4. Apologies for that, if you noticed that. Why didn't you speak up? Oh yeah, we're on a video, I understand. Okay, 24 divided by 4 is 6. K square root 2. Same. That is your full marks, but I would always advise when the question asks you to prove something, to show something, or to verify something. In this case, they asked you to show it. Just write a little English, write whatever they wrote to ask you the question. Just write, therefore, mean equals even is fine. Therefore, mean equals median. I guess you don't even need too much English. You can write that in English. Therefore, the mean is the same as the median. That's fine, but this is enough. Just tell them, state the problem back to them. That's what's always advisable. So on to part B. Part B is a proof. It asks us to prove by contradiction that the square root of 2 is not rational. You'll often also see the question square root of 2 is irrational. Irrational and rational are just the opposite. Don't worry too much for that. Now, I know you have a lot of proofs to remember, and so many students skip them, to be honest. They don't learn them. These are some of the lowest scored marks in any leaving cert. These will be these proofs. So here's a bit of advice how to do them. Because the students that do get them tend to memorize them, a lot of them. That's too much. It's a lot of work to do to try and memorize all the proofs you have in your leaving cert. I would like you to try and remember the start of each of them. How do I start this? How do I start? That's so manageable. That's I'm not sure how many proofs there are, but only so many ways you have to remember how to start them. And in the geometrical proofs, a lot of them aren't even the same. And then during the proof, there's that's the trick. So there's usually only 2 things to most proofs to remember. So do not get carried away trying to memorize step, 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 step. I'm not going to teach it that way because I don't remember it that way. I remember how to start these questions. How to start it is, let's write square root of 2 is equal a divided by b. Because every rational number looks like a divided by b. Every rational number can be made to look like this, where a and b have no common factors. Because every number can be wrote like that. Every rational number, at least, can be wrote like that. So, for example, nothing divides a that also divides b is what we're looking for. Because even though we come across things like that, 4 divided by 6, we can make this is just the same as, this is equal, there's 3 little lines here, it means it's just fully the same as 2 divided by 3. There's no difference. Every number can be got down to its most basic 2 numbers. They're not always small, it could be some really big numbers, but they can be got down to 2 basic simple numbers that don't get any smaller. or in fact they can't be got, they don't exist at all, which is in the case of here. No two numbers exist that will equal this. So we're just going to assume it does equal this, and we're going to prove it by contradiction. We're going to say something that I said is wrong. And just as a little hint, the thing I said is wrong is the A and B have, I hate writing out all this, have no common factors. I'll leave that here because this is the part we're going to find a contradiction in that statement. So how do we do that? We square both sides. Just play around with this. That's why I wouldn't say you need to memorize these middle bits, because once you remember this start, you just start playing around with it. Get a square root? Well, let's try squaring both sides. Equals a squared divided by b squared. Let's play around with it more. Let's move the b up here. We have 2b squared is equal to a squared. Now, here's the little trick inside the questions. That the next thing I would think you have to remember for this. When you get something here, this tells me something. It tells me something very important about a. It tells me something. It tells me that a squared is even. Let me say, why is that? Well, 2 times a number has to be even. 2 times any number is in fact even. Therefore, a squared is even. And even more, we could even write a. Well, let me write a whole new line. I guess. Therefore, a is even. If a squared is even, a must be even. The only way to get an even number by multiplying by yourself is to be even, or just actually more simply to say that an odd number by an odd number, an odd number by itself, which is in fact an odd number, will give you an odd number. An even number by an even number will give you an even number. So if a squared is even, which it is here because 2 multiplied by something is even, a must be even. So then we can write a is equal to 2k. Now what's k? Doesn't matter, it's just a number. It's any number you want. We'll deal with all integers here, it's fine. These are all just integers, the a's, b's and k's. But there's some number exists, because if a is even, there must be a number that exists that this works. So think a is 2, k would be 1. A is 8, k is 4. A is 16, k is 8. A is 1,000,000, k is 500,000. There's always exists a number if you're even. And if it's not even, 3, 1.5, that's not an integer. 7, 3.5, that's not an integer. There's no number that exists, in fact. So if it's even, this is true. A is equal to k. Okay, let's start again then. Let's go back up to this line here, and we'll go 2 is equal 4k squared divided by b squared. I'll just put this in for here. So let's rearrange this, play around with this so we get b equals. Here we got a equals, or a squared. So b squared is equal 4k squared divided by 2. b squared is equal 2k squared. This is very similar. 2 times a number is even. 2 times a number is even. Therefore, b is even. This is enough. This is probably already enough to answer your exam. B squared is even. Therefore, b is even. Because think of it. If both of these are even, you can say this in English. If both of these are even, they must both divide by 2. Which is, but we'll say a bit more formally. We'll say therefore b is equal to 2h, let's say. So if b is equal to h, and again there exists a number h, there has to. If b is even, there must be a number h that exists. So therefore, square root of 2 is equal to a divided by b. That's what we started with, which is equal to 2h divided by 2k. Oh, wrong way around. I'm sorry. 2k divided by 2h. So we said no number divides them both. No number is a common factor. Well, 2 divides them both. I can divide this by 2 and this by 2, and we get k over h. And we started with the smallest 2 we could get. So no, that doesn't make sense. There's 2 divides into both of these numbers, if that exists. But I said they don't exist. So that's a contradiction. So what I conclude is this whole case here doesn't exist. The square root of 2 cannot equal a divided by b. And we just write that at the end. You don't have to write all that in English. This will be enough for you. If you didn't remember all these steps, more English is better, I think, if you think you have an understanding of it. So the final thing, you would just write, therefore, square root of 2 is not rational. If you don't write this, the examiner will take marks away. They do want to see this one last line. Every proof, they ask you to prove something, they want you to show it at the end. What did you prove? Seems a little small thing, but most examiners might let you away with it, given if you got it exactly right. Okay, next video we'll be doing question 7. I'll see you then.